Now in this video, we are going to look at the absorption of three types of molecule just now, organic, inorganic, and complex. First, we will look at the absorption by organic compound. UV visible radiation can be absorbed by organic compound, especially the one that have heteroatom and the one with unsaturated hydrocarbon. Okay, heteroatom, as I mentioned before, we have nitrogen, oxygen, and sulfur, and also halogen. While unsaturated hydrocarbon is the one with double and triple bond. Okay. So unsaturated functional group, double and triple bond, which responsible for the absorption of UV, is called chromophore. Okay, take note for this ya. Yang ini pun selalu keluar exam, selalu juga ditanya, tak kisahlah exam ke test ke. Okay, so absorption of UV by organic compound cause the transition of electron from HOMO. This is the most often observed. Transition from HOMO to the LUMO. HOMO is highest occupied molecular orbital and LUMO is lowest unoccupied molecular orbital. HOMO is, kalau kita nanti sekejap nanti next slide saya explain what is HOMO and LUMO. Okay. Still about molecular orbital theory. When bonds are formed from the interaction of atomic orbital to form a molecular orbital, we will get, in the molecular orbital, we will have bonding and anti-bonding molecular orbital. Bonding orbital normally dia tulis simbol je lah, sigma, pi, okay. And anti-bonding molecular orbital normally is associated with the asterisk, ada simbol star ni. What is bonding molecular orbital? Bonding molecular orbital is the one that has lower energy and has greater stability than the atomic orbital from which it is formed. This one saya dah explain dah lah dalam slide yang sebelum ni kan. And anti-bonding molecular orbital has higher energy compared to the one compared to the atomic orbital from where it is was formed. Okay, this diagram shows energy level of a molecule that contain bonding orbital. Okay, below is the bonding orbital. This is anti-bonding orbital and N is the non-bonding orbital. Okay, so normally electron will occupy the lowest orbital first, the bonding orbital first. Then if there is an extra, then electron will be filled in the unoccupied molecular orbital ataupun anti-bonding orbital. And the lowest energy transition can happen between HOMO, highest occupied molecular orbital, and nitrogen, to lowest unoccupied. Lowest is the lowest unoccupied molecular orbital. Unoccupied is the anti-bonding. So the lowest of unoccupied is the pi star. Highest occupied is the HOMO. HOMO is the N. LUMO is pi star. Okay, so this transition is the lowest energy transition. Okay, in this picture is the example of energy level for bonding and anti-bonding molecular orbital in hydrogen molecule, H2. We have one hydrogen. We need two hydrogen to form hydrogen H2. So this is one hydrogen atom. This is another hydrogen atom. When it is formed, this is bonding orbital with lower energy, and this is anti-bonding orbital with higher energy. Okay, the disruptive interference, will form antibonding sigma molecular orbital, while constructive interference will form bonding molecular orbital, bonding sigma molecular orbital. Same for this one, these are two possible interaction between two equivalent p orbital. Just now is s orbital, now is p orbital, so we have P here, and this is dia punya same, dia akan form bonding orbital with lower energy and anti-bonding orbital with higher energy. The disruptive interference is the anti-bonding, constructive interference is the bonding. Same for this one, this is for okay, electronic transition. Electronic transition in bonding orbital to anti-bonding orbital occur when electron in molecule is excited by UV and visible radiation, UV or visible radiation. From the molecular orbital diagram, there are several possible electronic transition that can occur, and each of them has different relative energy. Okay, from energy level of molecular orbital tadi yang kita ada sigma, pi, and pi star and sigma star, dia boleh ada each transition, each specific transition with different relative energy. So this one show us the energy level of the molecular orbital. And this one you memang kena ingat, we have sigma, pi, and pi star and sigma star. And these are the possible transition, so kalau kamu boleh draw dekat sini dari jam dari mana ke mana, itu adalah possible transition yang kita boleh ingat, so kalau kamu draw kat sini, insyaAllah kamu boleh ingat. So it can happen from sigma to sigma star, this is the big one, tapi nanti kita akan tengok discussion dia, since dia adalah yang paling besar, so it require higher energy dan adalah tengok. The second one is from sigma to pi star. Okay, kalau sigma to sigma star tadi only in alkenes, in saturated compound, yang tak ada double bonds, but dia only have sigma bond je. Sigma to pi star is in compound that have sigma and double bond. Sigma ni semua molekul ada sigma bond, tapi tak semua molekul ada pi bond dan tak semua molekul ada n electron. The third one is from sigma to sigma star. This is for unsaturated compound, double and triple bond ataupun carbonyl, C double bond O boleh ada juga. Sigma, then we have n to sigma star, this one, n to sigma star, and n to pi star. Okay. This diagram also show the same thing dengan yang tadi tu. Cumanya dia lukisan dia bentuk macam ni lah. Energy level je dia tak ada yang macam tadi tu. So we have sigma to sigma star, pi to pi star, n to sigma star, n to pi star. Okay. Okay, for specific transition, first sigma to sigma star transition. This is actually never been observed in the normal UV and visible work, because the maximum absorption are below than 150 nanometer dia punya wavelength. Okay, and the energy required to induce sigma to sigma star transition is quite big. And this type of absorption correspond to bond breaking. Okay, so this is seldom been observed in the UV. Yeah. Okay, untuk specific transition ni, apa yang kamu kena take notes adalah dia punya wavelength. Okay, dia punya wavelength. This one, yeah, wavelength dia. And also, okay, wavelength lah. Yeah, wavelength. And what are the bond or electron that involved in for that transition? Okay. This is the second one, N sigma star transition. This happens for saturated compound and also have heteroatom, yeah, or unshared electron. Okay, compound contain heteroatom. Absorption in the range of 150 to 250. Okay, so types of electron transition and also dia punya wavelength region dia. Yeah? Untuk molar absorptivity value ni, not very important. Okay, another point is the peak is intense or not. Yeah, for example, this one not very intense. Yeah, for N to sigma. Then we have example of N to sigma star transition, yeah, macam ditulis tadi, between 150 to 250. Yeah. Okay, ini semua 150 to 250 nanometer. Okay. Okay, N to pi star transition, since it is pi, it must be unsaturated compound. And also have heteroatom or unshared electron. Yeah, this absorption intense and happen in the region of 200 to 700 nanometer. Pi to pi star transition, again for unsaturated compound, and the region is again the same with the N to pi star. Pi to yes, N to pi star, between 200 to 700. And this is some example of N to pi star and pi to pi star transition. Yeah, both happen in the region of 200 to 700 nanometer. Yeah, dia punya wavelength region dia. Okay, for this spectrum, this is a typical spectrum for UV. Kalau kamu tengok, this is for tetraphenyl cyclopentadienone. So we have pi to pi star transition. This is pi to pi star transition, and this is N to pi star transition, yeah, because dia ada unsaturated, dia ada double bond dan juga ada heteroatom. This is for isoprene, yeah. Isoprene, kalau kamu tengok dia ada pi bond sahaja, dia tak ada heteroatom. So we only have one peak je lah. Kat sini satu ni je lah. Kalau ni ada dua peak. Satu pi to pi star, satu N to pi star. Okay. From spectrum, we can use as a qualitative analysis. Yeah. Okay. In this table, it shows the absorption characteristic of some common chromophore. Yeah, remember chromophore? Chromophore is the functional, unsaturated functional group that absorb UV radiation. Yeah, tak perlu hafal lah dia punya lambda max ni. Just to show that it is happen in the region mentioned before, even though some are not very accurate. Yeah, molar absorptivity value dia dan juga types of transition dia. Molar absorptivity value dia not very important, tak perlu ingat. Yeah. Okay, this is a typical